We are going to start with the first speaker, this is Chloé Clavel. Chloé is working at the Almanac team at INRIA in Paris. And before that, she was a professor of affective computing at Telecom Paris, where she coordinated the social computing team, and her research interests are in the areas of affective computing and AI. Which is at the crossroad of multiple domains like NLP, speech, machine learning, and social robotics. So, Chloé, you have the floor, and I give you the mic.
Thank you, Laurent, for this introduction. And good morning, everyone. Thank you for this invitation to the seminar. My research work, as you can see on this picture, focuses on human and human-agent interactions. And for the nod to ChatGPT, which is not now a trendy discussion topic, these pictures have been automatically generated. But let's come back to my talk. I am happy to have this opportunity to present you my research work on multimodal analysis of the socio-emotional level in interactions, and to have your feedback on it. Today, I would like to present you this work on multimodal analysis, but with a specific angle, because what I want is to automatically analyze phenomena such as socio-emotional behavior. So we want to automatically analyze phenomena such as socio-emotional behavior. And to say it otherwise, my research work is dedicated to the replication by computational models of a subjective perception process, the perception by humans of the socio-emotional behavior of their conversational partners. And this replication of this subjective perception process is not an easy task and requires to address specific challenges that we will see together. So, before going further in explaining what I mean when I say that multimodal models of socio-emotional behaviors are dedicated to this replication of a subjective perception process, let's go back to what are multimodal models of socio-emotional behaviors in order to build our common ground. So the research of multimodal analysis of socio-emotional behavior is not so new, even so people are now speaking about it more and more, and it belongs to the research domain of affective computing that was born in 1997, thanks to the book of Rosalind Picard. And the objectives of this research domain are to develop both more natural human-computer interactions by integrating this socio-emotional level, or systems for the automatic analysis of these human-human interactions and of socio-emotional behaviors in these human-human interactions. So let's imagine you want to analyze the recording of the talk I'm giving to you, okay? You have input data, XI, a representation of the multimodal content of my talk, the verbal content, what I say, and the non-verbal one, how it is said, the intonation of my voice, the posture, the facial expressions. But this input data can be monologues, such as the talk I'm giving to you, or dialogues, human-human, such as call centers or human-robot interactions. And you may want to automatically analyze this multimodal content and to assign each recording a label. And in our example, we could be interested in assigning to my talk a level of persuasiveness, for example. But more generally, we want to assign a label corresponding to the socio-emotional behaviors that are expressed in this data. And what I will refer to in this talk as a socio-emotional phenomenon in my research is a set of phenomena that encompasses both emotions such as frustrations, opinions and social attitudes, and conversational strategies such as indirectness. But all these phenomena share this specificity. They are phenomena that are difficult to grasp, and we can start to realize here that understanding these behaviors means to replicate this subjective perception process. So, let's keep on building our common ground. What are multimodal models of socio-emotional behaviors? What are the methods or the models I previously used and I'm currently using in order to automatically analyze these behaviors from multimodal data? The oldest approach are rule-based ones. The idea is to build multimodal or monomodal patterns, such as shown in this figure, featuring a class. And in this example, you have an illustration of such a pattern that we defined recently in order to model a phenomenon that is edge. Edge is a pragmatic competence linked to indirectness that we use in order to mitigate the social imposition of a proposition. In other words, not to be rude. For example, if I say, it seems you are wrong, I'm mitigating the social imposition of my proposition rather than if I said, you are wrong. So I put here the simplest pattern, but you can have a look on this paper to see the patterns that we defined in order to include the nonverbal information, so both gave shifts, for example, and the rule-based approach that we used here was because we wanted to model a phenomena that was not well known in the literature. So that's why we use such rule-based and then handcrafted features. But rule-based approaches were used some decades ago, but they have the merit to make explicit the rationales behind the automatic assignment to the class. Thus, they provide a high level of interpretability. More recent approaches are the supervised machine or deep learning approaches. The supervision comes from annotated data. Each video is assigned a class by a human, for example. In this paper, these are human-robot interactions and annotated with user engagement. And it consists of the learning of a model able to distinguish among the class. The models can rely or not on crafted features or be a fine-tuning of foundation models. And in this paper, in particular, we use multimodal feature design for training a neural model capable of analyzing the user's engagement in their interaction with the robots. So the last approach, where the third type of approaches for computational models of socio-emotional behaviors is the prompting of the generative foundation models, the recent turning point. Generative neural models are models capable of generating texts, and we can use them for classification purpose by reformulating the classification task as a task of generating an answer to a question and about a context. So here, for example, to automatically analyze the level of surprise of the end of the story. So here we put the story in the context, and we ask the question about the level of surprise to be assigned. So here it's a regression task that has to be written in the prompt. So, as well said in the paper, do language models enjoy in the title of the paper, the objective was to investigate whether or not we can use a large language model with prompts to automatically evaluate generated stories. So, I think that we have now a common ground on what I call multimodal models of socio-emotional behaviors and on the types of methods that are behind these models. Now I can highlight the scientific hurdles and the research question I'm tackling for this research. For all the types of approach, using foundation models, rule-based, prompt-based, the phenomena that are socio-emotional phenomena and that we want to model are complex to define. Therefore, the level of expertise required for the supervision of the training, fine-tuning, prompting is high. An example that I like to give is that it's more difficult to annotate the user's level of trust in an interaction with a robot than to annotate a cat in an image. Okay, so you can see that the phenomena that we want to detect or to generate are complex ones. For such a human annotation task, there is therefore human label variation, and then difficulty to define a consensus. In the same time, the decision-making process behind the automatic analysis is strongly influenced by the data and the human annotations. So to address these scientific hurdles, to my opinion, we need to focus our research in such a way as to try and answer two research questions. First, how can computers' models reflect the consensus between human perceptions and reflect the complexity of socio-emotional behaviors? Second, when the models are built, we need to ensure that they are transparent with the subjectivity that they encode. We were building reasoning rule-based model using explicit social rules. We were using that. We were able to provide to the human partner of the interactions or practitioners information of the decision process behind the automatic analysis of the human socio-emotional behaviors in conversations. But the most trendy and recent approaches based on large language models are very opaque, as well as the decision process behind them. So this research question is crucial because we need to try to understand what is the culture also behind the design of the agent and what stereotypes it reproduces and so on. So, because in this research domain where you develop machine learning models able to model this socio-emotional level of the interactions, it's important to think about why you are building your models and who will use them. For my research, I'm privileging applications where models are used for human skill improvements. Applications in education where computational models of socio-emotional behaviors are used in, for example, public speaking training systems, or the development of social robots as learning partners. And application in health with the study of speech emotion expressions of Huntington disease patients in order to assist neurologists in the monitoring of the patients. So here you can see different applications on which I work on. I would like to present you now why I think the two research questions I previously defined are important within the scope of applications. I can take the examples of the health applications I just mentioned for the first research question. For your record, we are working on this development of speech emotion recognition system to analyze Huntington, the emotion expression of Huntington patients. And for this application, the first research question is crucial. Our objective is to model a complex phenomenon, try to reproduce an expert annotation of emotions in the speech of Huntington patients. We need thus to build a consensus among various expert annotations before trying the recognition models. I will take now a second example of application, the one of public speaking training systems. We have been working on explainable machine learning models for the automatic analysis of persuasiveness in public speech to be able to give feedback to the speaker. For this application, the second research question is really important because we need the learned model to be transparent with the subjective aspect of the perception and to try to take into account the cultural differences that we can have in the perception of the talk. Some of you may find my talk very persuasive, some of you not. It depends maybe on your community, okay? So, but maybe all of you will not find it persuasive. Now I will enter in the first research question about the ability of the models to reflect a consensual perception of socio-emotional behaviors and their complexity. I would like to share with you now research directions we started to take in order to address this research question and what we've done so far in our team so that you can give me your feedback also as a starting point for the next discussion. So let's go further to what is behind the research question. As I said earlier, it's difficult to define a consensus between human annotations when we annotate socio-emotional phenomena. But what are our research practices in our research community? First, we design annotation scheme grounded on social science, for example, psychology for emotions, and then we ask several annotators and measure to annotate the data, given this annotation scheme, and measure their agreement, in order to build a consensus from this annotation and train a model from this supervision. Let's note that by doing that, we have the ambition to define a universal model shared by all, but we will see later that a model is always subject to subjectivity. And even if we try to model this universality, we encode biases on which we need to be transparent. And this is what we will develop later when presenting the second research question. So regarding the ability of the models to reflect or encode the complexity of socio-emotional phenomena, the first step is to better define or formalize this complexity, and the literature in social sciences provides material to describe what constitutes a social interaction. So we can rely on this literature and then make this formalization accessible to machine learning models by working, this time, on the model design. So using social science literature to work on the model design. So what are the examples of our research dedicated to this formalization from social sciences? We rely on various theoretical frameworks. For example, psychological models for emotion or interactional sociology for trust. Regarding trust, the interactional sociology helps us to define the list of observable behaviors to annotate. For example, here, I don't know why there is this. This is just a problem of display. don't try to decode it. So I think this is a reference of the paper. You have to decode. So regarding trust, the interactional sociology helps us to define the list of observational behaviors to annotate, for example, self-disclosure, to signal the user's benevolence in her interaction with the robot. Let's remember that the goal here is to use these theoretical models to define annotation scheme first, and then build a consensus, and then train a model on the supervision. Second, for model design, to model this complexity, find architectures, training objectives that are able to model this complexity. So we developed such a methodology for various phenomena: trust, disengagement, age, appeal to emotions in fallacies, emotional expressions, in different data, human agent, and human robot, but applying the same process, okay? And to go back to trust, also in this paper, what was interesting for trust is that we also showed that using different theoretical frameworks, for example, there were psychological framework for trust, or framework coming from interactional sociology theory, can lead to different labels, depending on the theoretical framework that we used to build our annotation scheme. So, but how to make the model reflect a consensus of the perception of socio-emotional behavior? For such an objective, our efforts were concentrated on obtaining labels for the supervisions that corresponds to this consensus. In the simpler cases, we rely on majority votes for building the consensus. But in our research work, we tried to favor expert annotations. This is what we did when we asked neurologists for the annotation of emotions of patients. But when it was not possible, we resorted also to non-expert annotations, using more annotators here. So with expert annotations, we have less annotator, but with non-expert annotators, we need to use more annotators using crowdsourcing platforms for the consensus building. And this is what we did, for example, for the annotation of persuasiveness of public speech. But what is, however, building a consensus using majority vote has some limitations, okay? Because inter-annotator agreement for socio-emotional behavior is usually only moderate, okay? Disagreements are always interpreted as noise. The data where people are disagreeing, we remove it from our experiments. And for subjective tasks, while for subjective tasks, equally valid annotations can coexist. So Therefore, we addressed this issue recently for a task, a specific task, which was the detection of fallacious arguments in social media. So if you are not familiar with fallacy, in this figure, you can see an example of a false dilemma fallacy. You're with me or against America. So this is a fallacious argument. We quickly noticed that depending on our cultural background when annotating fallacies and political affiliations, what is considered a fallacy differs. So we propose then a disjunctive annotation scheme at the span level in order to allow for several alternative labels for the same span and build evaluation metrics from these alternatives. So this was a way to introduce flexibility in the supervision of the models to allow various different labels when the fallacy was not a problem of logic, because you have fallacies that are not always just arguments that are not logical. So, but beyond this work on making a better supervision for models, we also worked on model design in order to make the formalization taken from social science accessible to machine learning models. We did it in 3 different ways. The most simple and explicit way was to design features to build the vectors for representing samples. The features were designed from the linguistic theories. So for example, this is what we did for hedge. We used linguistic theories defining hedge in order to define patterns of characterizing linguistic expression of hedge. A second way, more in line with the recent ways of representing data, is to work on more dedicated neural architectures. For example, this is what we did here. In this paper, we investigate the modeling of the conversational dynamics within the few-shot learning frameworks. So the idea was to using relevant architectures to model this conversational dynamics even with a few-shot learning framework, which was prototypical neural network. Finally, but less interestingly, from my opinion, this expertise can be formalized in prompts. And this is what we did for the task of evaluating automatically a story according to various criteria. The criterion evaluated in this prompt is how surprising a story is. But beyond, so in the first research question, we assumed more out of necessity than conviction that we could try to construct these universal models of socio-emotional behaviors, and I have presented the type of methods we used in order to make the formalization accessible to machine learning models. But this is a partial universality, since, as we mentioned in the scientific hurdle, as we mentioned it in the scientific hurdles, the models encode the subjectivity of the data on which they were learned, as well as the annotators used to supervise the model. And the question I'm raising with you now is how to dissect these models, or at least understand what is encoded in the machine learning models. So I have chosen to present you 2 examples of studies. The first one is the investigation of the LLM's ability to provide explanations, and the second one is dedicated to the understanding of human subjectivity by dissecting supervised neural models. We mentioned in the research questions that recent deep learning approaches are opaque. Nevertheless, as language models scaled up, explainability is more and more associated with prompting, which means that, as you may have noticed, you have no the possibility to obtain explanations, such as in this example here. This is the LLM's explanation for the task of evaluating a story with respect to the reader's engagement, which is a subjective task. We conducted user study on this explanation. So we ask several annotators to identify various potential issues in LLM explanation using and try to identify this the following issues: poor syntax, incoherent, superfluous text, substantiated claims. And we, okay, thank you. This study leads to two main results. 40% of the rating are not supported by an explanation, despite the prompt explicitly asking for it, and 31% corresponds to unsubstantiated claims. We should do this study again because maybe it has evolved. It was recent, but you know now that the things are evolving a lot. But we have the evaluation protocol. The take-home message is that we cannot ensure so far, at this stage, the reliability of LLM evaluation as well as the LLM explanation. The second research study was about the study of attention mechanisms and the dissection of supervised neural models. Our purpose was here to study the cues that models are using to make their prediction. So our purpose here, the context of the study was here to address this research question. What are the social signals that are impacting a recruiter's decision in the interview, in the job interview? And I will go quickly on this study. So we study these attention mechanisms in order to see where attention slices were, and the results were that attention slices tend to occur at the beginning or at the end of an answer, and contains more breathing, fillers, or activation of some action units. Such as these that are linked to confusion and emphasis, and specific vocabulary linked to competencies. The take-home message here was that this is just a step towards explainability, because we should do a user study in order to see if what the cues or the moments that seems to be important, thanks to attention mechanisms, are really important or not. But we can try to dissect a model. It gives some information, but this is very local, and we cannot completely retrace the decision process, such as it could be done when using reasoning models. So the key takeaways to conclude, let's go back to our research question. Regarding the first research question, we discussed the need for methods able to encode explicitly the socio-emotional information in the models. We described some research work that we did for that, definition of attention scheme, design of features, prompting of LLMs. But I didn't have the time to mention here that we also worked on this first research question for the generation part, because this research question is also crucial for the generation of agents' behavior. And we worked on agents co-speech gesture generation, agents net strategy prediction, and we have work in process also on modeling other phenomena such as multimodal repair in human-robot interaction or abusive language in social networks. And to conclude on just the second research question, to be fair, I've presented user study to understand the reliability of LLM's explanation, attention mechanisms used in neural architecture, how we can use it to provide us local explanation. But we have other work in progress on these classification models, providing reliable explanations that are understandable by user for public speaking. Our generation models, transparent with a socio-emotional strategy also, used in the generation process. So because now with the end-to-end LLM, we don't have this explicit stage of socio-emotional strategy prediction. And we are also starting to work on the ethical and cultural background of the generation models in dialogues. Just to conclude, last but not least, the work represented here is carried out by with and by my collaborator, that you can see in order of appearance in this presentation. So, thank you.
Thanks a lot.